Hello and welcome everybody to this first session in our series of CE Tech Talk. And the purpose of these sessions is basically to provide a platform for knowledge sharing across the business, where we can share our experiences and tips and tricks when it comes to how we can use digital solutions to increase productivity and also, of course, to provide even better services to our clients. And today we will hear from Marco, who will show us how he and the team transformed a very tedious and repetitive task of analyzing hundreds of long text documents, and they turned that tasks into an efficient process with the help of AI. And even if AI, of course, is an area that is, developing super quickly and where I'm convinced that there is a lot of for us as a company to gain, it's important for me to say also that we will cover more than just AI-based solutions in these sessions also going forward. So if you have something that you think is worth sharing with the rest of the colleagues in any of these sessions, or for instance, if you know of a colleague who has done something that you think might be worth sharing, please do reach out to me such that we can, fill the content of these sessions going forward with some good and interesting content. But without further ado, I will just hand over the word to you, Marco, to take it away for the next 43 minutes or so.
Perfect. Yeah, thank you, Anna. I will start sharing my screen if I get that to work. Yes, I guess you can all see my screen now, right? Cool. Yeah, thanks again, Anna, and welcome everyone, and thank you for showing up to this first tech talk of this longer now series that I will kick off today with yet another talk about the use of ChatGPT, but I will define the word use in a slightly different way that we are probably most of us are used to. Because today I want to advocate for using ChatGPT not merely through its classic chat window, but also through its application programming interface, or in short, API. Right? So let me start with the motivation. By doing that, I wanted to briefly outline of what I think and how we're using ChatGPT most often. Well, in the most simple use case, I believe we are using ChatGPT as a substitute for Google. We can ask it questions like this. Please explain in simple terms and not more than 2 sentences what an API is. And then we get a very specific response, which I think is an improvement over Google because we don't have to click around that much. We get a tailored response. We don't have to search for the response, but it's still a very simple case, right? We're all used to that by now. Then there might be a bit more of an advanced case here, at least for those that are used to working with the pay version of ChatGPT, GPT-4 that is. In the lingo of LLM, what I'm showing you here on that particular slide is referred to as tool use, because in addition to the standard input prompt, I am now allowing ChatGPT to use an additional tool to increase its input content. I'm allowing it here in particular to access Python, and I'm giving it an Excel file or a CSV file actually, and allow it to analyze that file, right? So in that particular case, I'm asking it to analyze all the World Cup matches that are football World Cup matches that were that are displayed in this CSV file, and I'm asking it a bunch of questions. So what I'm trying to get here at, and this is also what I want to talk about more in what's following, I'm allowing ChatGPT to extend its knowledge base. I mean, this example might not be the most instructive one because obviously it has been trained also on World Cup matches. So it basically knows the answer even without to all these questions, even without passing it this CSV file. But you get the sense, right? I could pass it any kind of Excel, Word, CSV file, and thereby increase its knowledge base. And this is what I'm doing what we are doing in this project. And so far, we are still in the classic chat window. But yeah, what do we do when we have hundreds of long documents? And this is really the question that underlies this talk today. If we want to analyze them, right? If we have reports like this that are mostly text, some tables, but really mostly text, right? And rather dull text. And then they're also quite long. They're 150 pages long or even longer. And then, yeah, as I said, mostly text, right? So this was the situation that we faced in the Orphanet project with, 380 reports from the European Medicine Agency. And each report contained information that we wanted to analyze in order to better understand what's going on in this process of drug approval, right? And there were basically two tasks that we had. The first one was to identify and extract relevant information from each of these PDFs and save them in an Excel file. And the second one was to analyze the sentiment of a specific chapter that occurred in each of these reports. Now we are running into these problems that I alluded to in the beginning already, right? We have a lot of documents, 380, and each of them are quite long. So if we read them manually, well, that takes forever. And unfortunately, we cannot even just pass it to ChatGPT because the amount of text even extends ChatGPT's content input, right? You cannot pass, there's always a token limit if you want. Tokens correspond to words. And if reports like these have too many words, well, then it won't really work, what we're trying to do, right? So these are the problems that we're facing or that we used to face in this project, and we had to find a workaround to deal with them, right? So now this is where the API of ChatGPT come in handy. And I think they come in handy for at least 3 reasons that I will discuss on the following 3 slides. The first one is scalability. The second one is we can allow to customize the GPT in a way that it really suits our needs. And the third reason is we can integrate it into our other programs, or we can integrate our outputs, if you want, into programs and directly continue working with the output rather than just copying it to an Excel file, then going to R and then analyze the data in R and so forth, right? So we can just write one script and then everybody can follow that script even 2 years from now. It's completely transparent what we're doing. So these are at least 3 reasons, and let me again explain them very briefly. So scalability, yeah? Now I'm going back to the example in the Orphanet case, right? Imagine you need to extract the same information over and over again from 380 documents. Again, doing that manually would take forever, so it's quite obvious that scaling this process up in some form of like automated way in Python or R is much more efficient, right? And we can do that with using ChatGPT's API because we can just integrate that into Python and run a big loop. Customization. Well, imagine you want the AI to produce answers that are replicable. That doesn't always turn out to be an easy task, right? Because I guess you're all familiar with ChatGPT by now, and you've encountered situations where you've asked the same question twice, but you don't really get the same response twice. And that's because a setting that is called the temperature setting in ChatGPT, that I will explain that a little bit in more detail in a second. But in some sense, we can play around with that when we access ChatGPT through its API. We can play around with settings and a lot of other settings and customize the AI to our needs. And then we have, as I said, the integration part. We can just spare us the work of a lot of copy and pasting from one document into Excel and then maybe open R, and then we always have to jump around between different windows. And we save basically a lot of time by just staying within one framework, write one script that then we can just reuse all over again and maybe improve here and there. Right? So these are the 3 key benefits that I see. There are probably more, but at least for our work in that project, those turn out to be the most important ones. There's also one big disadvantage, maybe two, that depends on whether you like coding or not. But there's one big disadvantage, and that is common for all of us, and that is, well, using ChatGPT's API costs money for each request. Well, it's a little bit annoying. So it means that even if we have the pay version, we still have to pay. And it really depends on how much money we spend, because it depends on what model we use. If we use a model like GPT-4, it can easily get very expensive, as you can see here. I don't know if this is too small, but I hope you can read this. We spend about 3 cents for every 1,000 tokens. A token roughly corresponds to a word. So for every 1,000 words, we spend 3 cents. That can easily get very expensive if we have long documents, and there are many of them. And then we can also, so if we give it a lot of input in terms of tokens, that blows up the costs. If we use a powerful model like GPT-4, that blows up the cost. And if we ask for an extensive output, that will also increase the cost. So in some sense, yeah, it's annoying we have to pay money, but we also have a lot of agency over how much money we want to spend. Because as I said, we can easily blow up the cost for the task that we're doing, that we did in the Orphanet project. If we were always to analyze the full document using the most powerful GPT models, we would easily spend more than like $3,000–4,000. So we have to be careful about using powerful models, running them over a full text, even if that is possible. I will tell you that that you cannot even run longer documents over ChatGPT over very long documents. But even if you could do that, it would very easily blow up the costs. So this is the one big disadvantage that I wanted to talk about. And this was sort of my introduction. And I wanted to ask at this point into the round if there are any questions at this stage before I move on. I cannot really see the chat, but Anna, maybe you can you see anything?
Nothing in the chat so far.
Okay, very good. Then just move on. Before I move, well, actually to our use case, I make a very, very small detour, a couple of slides, because the actual content that I'm just diving into the code can be quite technical, and I want to make sure that we all understand the technicalities that I will talk about. So I hope that the little detour that I will do now in the following will help you to understand what the technicalities entail later on. So very briefly, what is ChatGPT and how does it work, right? So GPT stands for Generative Pre-trained Transformer. Generative means, well, it's producing text. Pre-trained means it learned from a massive amount of data. And the transformer, well, that's the machine learning model. And that's really where the magic happens, right? And the transformer, in a sense, really in a nutshell, takes a piece of text and then based on its training, produces a prediction for the word that is to come next, or for the token, which roughly corresponds to a word that is to come next, right? So for the example here that I'm showing you, the cat chases the, right? There's a lot of words that come in next now. It's the job of the transformer to find out which word would fill in that blank here, right? And it's essentially assigning a probability to the whole space, to the whole set of words that exist in the English language, or at least the ones that it has been trained on. Most of them have a 0 probability, but some of them don't, right? Some of them have a higher probability than others, like mouse. And then, probability decreases, and you would hope that they all sum up to 1 eventually, right? So this is the job of the transformer in one sense. But then, because we're dealing with computers, right? A word really is no longer a word inside the transformer. It's actually a vector of numbers. Why do I get so technical at this point? Is because this will be very, very important for what I'm going to talk about later on. So please bear with me here. A word is a vector of numbers, and these numbers are outcomes of the training process, right? So for example, think of the word queen as a vector like this, right? In reality, this vector will look much, much longer. I think it will have like 12,000 dimensions. But think of it like this, right? Just a set of random numbers or seemingly random numbers. They're not random. They're an outcome of pre-training, of a training progress, right? And what is cool about the fact that we're now representing a word with a vector is the fact that a computer is much, much better at dealing with numbers than with words. And these numbers and these dimensions of the vector, if you want, are representing the meaning of these words, right? And now, since we have vectors, numbers, we can perform math operations with it, right? So for example, we can roughly calculate the word queen as a sum of, king minus man plus woman. Because, well, king and queen has the dimension of this royalty dimension, but it also has this sex dimension, right? And if we're dealing with both, we can roughly calculate the word queen now, right? So that's pretty cool, right? And that's important because the transformer now is able to assign a probability to each of these vectors and the corresponding words, which will allow us to, predict the next word that's coming into the sentence. So now I'm circling back to my example of the cat chases the blank. So now one would expect that the transformer always picks the word that has the highest probability, right? So now in that particular case, it should probably be mouse. But it turns out that this isn't like the best use. This isn't the best scenario, right? In a sense that when we do that, it turns out that the texts that the transformer produces sound rather flat. And that's apparently not what OpenAI and these large language models designers, developers wanted, right? They wanted to have a text that is a little bit more creative. That's where the voodoo of the temperature sort of comes in. Because the temperature now, depending on how high it is, chooses not just the word that is most predictive, but it might choose words that are less predictive, right? And thereby, we're generating text that is always slightly different and always a little bit more, in a way, creative. But sometimes that's not what we want. Sometimes we just want a text that is very predictive and thereby replicable, right? So we have to fiddle around with that temperature setting. We cannot, well, you can do that in the chat window. You can tell it, ChatGPT, to turn down the temperature, but that means you have to do that all the time and you have to remind it again. Now, when you work through the API, you can just set that once. And just because I think it is so important, here's an example of the temperature for 2 emails that I wrote. Maybe you take all a minute or so to read these 2 emails just to understand how the tone changes from the default temperature setting in ChatGPT, which is 0.7, to the most predictive one, right? I think this is a pretty cool example. It's very different from the case that I want to talk about, but I thought it was so useful for our daily work that it might make sense for you to get a sense of what the temperature does. All right, so this was my little detour. There were 2 takeaways, or 2 things that I want you to take away from that detour, or what I'm going to talk about next. That was A, words or tokens are not really words, they are vectors, which is great because that allows us to perform math operations. And computers are pretty good at dealing with numbers, right? And they're accurate and they're fast. Second thing is the temperature setting, which is really just one example of how you can customize an LLM. But it is one that I find extremely useful even for our daily work. So I wanted to bring it up here, and it will also be useful later on. Now, with that said, let's circle back to and finally come to our actual case. To extract unstructured information from a document or from hundreds of documents and store them in a way that so that we can analyze them further. And I promised you in the teaser that I will walk you through step by step through that process. And so I will do that. So we start out by collecting our API key from OpenAI, because I said, well, this is a costly process, so we have to link this to an account, and this is done through an API key, right? So the first thing, and I'm always working here in Python, is to link, to access ChatGPT through Python, and I do that through the API key, right? So these are the first lines of code, rather simple. We could also do that in R, I think. There will be a couple of steps later on because we need packages that we cannot run in R, which is a bit of a bummer for the kind of work. I know we're working a lot with R, but for this particular task, I'm afraid this would only be possible in Python or JavaScript. So yeah. Then we have the second step, right? So now we're getting closer to our documents, right? We take one of the 380 documents. I started with one that I'm familiar with because it's dealing with a drug that I have encountered in one of my projects before. I'm telling Python, well, go to the folder where all my documents are stored, and then take a file that's called Oladeo and then something else, PDF. And Oladeo is a drug that is for a rare disease, hereditary angioedema. So I know a little bit about this, and I wanted to make sure that I'm generating outputs that I can verify. So the first step, or in that second step now, what we're doing is we're extracting the raw text of all, of all the pages in that document, right? That's the first task. But now it turns out there's a lot of information in that raw text, which is rather useful for our analysis. There are page numbers, which don't really help us. There is information on the front page that don't really help us. On the last page, there are unnecessary line breaks. So there is a little bit of cleaning, of text cleaning, if you want, which is an annoying process, just like data cleaning. But it's well, you have to do it, right? And this is what I'm doing here. It's a predefined function that I cannot show the code here because it's just way too long, but it's just one function that I apply here. It's called clean text. That is cleaning all my documents. Now we have the text, right? So now we can start defining our GPT, right? We want to use the most powerful GPT because, well, we want to make sure that the output that we produce is reliable. So let's start with the most powerful GPT, GPT-4, which is also the more expensive one, but okay. And then we can customize the GPT, as I said before. I'm really doing just the minimum on this page here because I didn't want to spend too much time here, but there's a lot of things you can do. But among other things, I'm setting, again, the temperature, right? Because, again, we don't want a very creative response here. We want a response that is true, and we want a response that is replicable. So if we do this task again with the same document in 2 years, we get the same response, right? And the chances of getting the same response and to get them high, we set the temperature to 0. And I'm doing one more thing. I really want only very short responses, and I could tell it every time, please give me like a short answer. But then it's not really clear what a short answer or a short answer is. Even if I told ChatGPT give me an answer in 100 words, it's not really able to count words. So what I'm doing here is I'm defining the set of tokens that it can use. It's really a bit, I'm allowing it to only compile an answer within 100 tokens, which corresponds roughly to 100 words. Most of the time, I only care about a yes, no, unclear response, which I could generate in like 2 or 3 tokens. But I also want an explanation sometimes, and I want this explanation to be short, and that's why I am allowing for a slightly longer response. But I will get to that. You will see that in a second, how the response looks. So now we've accessed ChatGPT. We have cleaned our text. We have defined our large language model. So in a sense, we're good to go, right? We can just, channel in all the information from the document and then, ask some questions about the information that we want and get those information, right? This is step 4, right? We extract the information based on a specific question. Question we're asking here, is the treatment indicated for prevention, right? This was a kind of question that we asked. And then we're giving it some more instructions as to how the answer should look like. It should be either yes, no, or unclear if the information isn't there. Then we're telling it to also provide a short explanation in the amount of words that we told it to, right? And then we're giving it, now this is looking a bit complicated, but in a sense, we're giving it the whole input, right? We're giving it the whole text. And what happens is, well, we get an error message. And that's because the document is too long, right? It's basically telling us the context length is 16,385 tokens. This is what it can handle. But my document resulted in a token input of 100,000. So this is exactly the problem that I told you about in the beginning. We're dealing with a document that is just way too long. So we have to find a workaround for that. And this is where now the coolest part of this exercise starts. How do we deal with this token limit? Right? We're chunking down the text into chunks, and we find the chunk that best answers our question. Right? This process is called retrieval augmented generation. Now let me walk you through this big figure here. We start out with this long PDF on the left, right? What we're doing then is we're creating small chunks. On this figure here, it's 4, but in reality, it's more like 100-something chunks. And then we do some magic, right? And this is why I wanted you to understand how a word translates into a vector, because similar to what's happening with ChatGPT, where a word is translated into a vector, we are now translating these sentences or these chunks into vectors, a process which is called embeddings, right? So we're taking each chunks, and through some additional machine learning technique, we are now translating them into vectors. And these vectors, like for the vectors before for words, keeping the meanings of these sentences or the text that is in each chunk, right? So in a sense, we're again dealing with vectors, numbers, but we're keeping the meaning of the text that is in each chunk. Now we're storing these vectors in a database, in an external database. And now we can bring in ChatGPT. We can ask our initial question, which was, is the treatment indicated for prevention? And we're doing the exact same thing with that question. We are translating it into a vector through this embedding process. And now we have vectors, one for each chunk, and a vector for our question. And now what we can do is we can compare the vectors, the vector of our question, with each of the vectors corresponding to one of our chunks. And then we're pulling out the chunk that is closest in meaning, or in vector space, which is same as meaning in this case, to our question. And we're pulling out the vector, in this case, vector number 3 or embedding number 3. And then we're compiling an answer to our question, which is only based on chunk number 3. Okay? So we are storing vectors in a database, pulling out the one that we need, and compile an answer. Now, why is that cool? Because the text chunk number 3 is much, much smaller. It's so small that we can easily pass it on to ChatGPT. We get around this problem of the token limit. But we've also saved a lot of money, right? There's a lot of information in all of these text chunks that are not relevant for our answer, and it would be a waste of money if we ask ChatGPT to read through all of them. So now we're just like allowing it to read through the chunk that matters. and thereby saving a lot of money too. So this is how it works in theory. Now let's go back to the code and see how this looks like. So we're going back one step. We don't immediately ask our question. First, we're chunking down our text, right? In fact, we're chunking it down to a text size of 1,000 characters. And we always try to find the end of a sentence that is closest to the 1,000th character. So it might not be exactly 1,000 characters, but it's always stopping at the dot that ends the sentence closest to the 1,000th character to make sure that we're not, cutting off some meaning in the middle of a word or in the middle of a sentence. And then we do this for all our raw text. Then we end up having a lot of chunks. And then we're doing this embedding process that I referred to on the slide before, right? And transforming each of these chunks into vectors of numbers and storing them in a database, which is this last line of code over here. This database is called PICE. Right? So we're storing each original text chunk together with its embedding. This is what we do. And now we can ask our question again, right? So we ask our question, is the treatment indicated for prevention? We give some further instructions. And then, and this is what happens in this line here, we are going through the database and compare each of the text chunks that are stored in the database and find the 3 text chunks. So I set it to 3. If we find the 3 text chunks that are most similar in meaning to the original question, right? We don't care about the instructions because the instructions have no meaning whatsoever. They're just there as instructions. But we compare them. We compare the meaning or the sentiment, not the sentiment, the semantics of the chunks to the question that we asked. Now we're pulling out the 3 ones that are most important, giving them to ChatGPT, and compile a response. And then the response could look like this, right? So again, we're getting a response, the one that we care about, which is a yes, no, or unclear response, right? Which is exactly what I wanted. And then I'm also asking it for a short explanation. This is just for us to verify, in case we want to verify whether the response is correct. But it's also, formatted in a way that we can easily, cut away this additional explanation, because what we really care about for further analysis is just a yes, no, or unclear response. Okay, so this is really the key thing that happened in this process of work. Now we can save this information. We have this stored in a variable. We can save that in a data frame and then convert that data frame into an Excel file, which is just a few lines of code. And then we can replicate that procedure for all of our 380 reports and all of our, I think it was 12 questions for each report, which is basically just a long loop, right? We're looping over all the documents in our set of documents. And then we're asking 12 questions in a similar way that I showed you 2 slides before. All right, so this was the scaling process, which I think is a big plus of working with ChatGPT and its API. But now you remember there was the second thing, right? We also wanted to get this sentiment. And that turned out to be a very different task, because if we want to get the sentiment of a specific text or a chapter at least, we cannot really deal with text chunks anymore, right? Because we want the sentiment to be built on like a full chapter or a full text, not just a few thousand characters. So in a sense, we're skipping this retrieval augmented generation step that I just explained to you on the slides before for this particular task, the sentiment task, and instead do a lot of slightly annoying data cleaning work in Python, because we needed to extract a specific chapter now, which is hopefully not long enough to violate our token limit. And it turned out that in most cases, I think in 95% or 96% of all the documents, it wasn't. And we could just pass on the entire chapter that we then extracted to ChatGPT, and then ask once again the question, a question, which in this case was the sentiment of the chapter, rate the sentiment on a scale from -5 to 5, and then allow ChatGPT to run this sort of sentiment analysis. Yes, this is sort of what we did. So let's very briefly summarize. We started out with these reports, right, that looked like this, very unstructured. We ended up with an Excel file that looked like this. It also looks a little bit unstructured, but that's because there's a lot of explanation in here. But in a sense, what we care about is the yes, yes, no, unclear, yes, unclear response. And that is very systematic now. Unfortunately, I cut away a little bit or I very much cut away the sentiment score. I'm sorry for that. But we also have the sentiment score in the last column here. All right, now let me wrap up. We encountered a couple of problems, right? This wasn't a very straightforward process. We had to do a lot of prompt engineering to find the right questions. We also dealt with cases that were slightly more complicated. If an answer is in the document, if the answer is affirmative or a yes answer, it would find the answer in 99% of the cases. The problems occur when there's no answer to the question in the document, because then sometimes it might generate a no answer, but sometimes it might also generate an unclear answer. And it's not perfect, and it cannot be perfect, because if a response isn't there, sometimes it can infer from the text that the answer should be no, but sometimes even though it should be a no answer, it might not infer that and just tells us that it's not clear, which is fine, but it's not perfect, right? So this isn't a perfect process, and this is all I wanted to say. Overall, I think we still provided a lot of, like, this procedure provided a lot of benefits. I mean, in the end, we spent only, this loop runs for a few hours, costs $40, but this is so much cheaper overall than having this done all manually. So overall, I think it was still a very, very useful exercise. Another question that I wanted to bring up to you is, do you see further applications, or do you have any further questions, or do you see any problems with such an approach for other types of work? Thanks.
Can you see the hands, Marco? Marcus has a hand up.
Yes, thank you for the presentation, Marco. It was very interesting and I learned a lot. But I have a question about the temperature which you can set for ChatGPT.
Yeah.
Is it something that you should think about like a seed, that if you set it to 0, it's just a seed and it's just a random number generation? Or should you think about it as, if you set it to 0, it will always reproduce, and if you set it to 1, it will never reproduce?
Yes, thank you. That's a good question. It's actually not a number between 0 and 1. 0 is the lower bound. So if you set it to 0, it will always, as I said, choose the word that is most likely to be the next word, right? The word that is assigned the highest probability. And that should give you a very, very predictive answer, replicable answer if you want. The upper bound is not clear. It's technically infinity, but in a sense, I think OpenAI restricts the upper bound to 2, because every number that is above 2 basically just generates random words. At some point, it's just picking words that have such a low probability that the text doesn't make sense anymore. So, and I think they played around with it, and at some point realized that 0.7 is the perfect temperature. But I think the perfect temperature really depends on your use case. And for our use case, it was definitely not 0.7. If you want to write a very creative text, maybe. But even for the emails that I write, it's usually suggesting words that I would never use. I mean, I probably know them, I've heard of them, but I would never use them when writing an email myself. But yeah, the upper bound is not 1. It's technically infinity, but I think you cannot set the temperature higher than 2. Does that answer your question, Marcus?
Yeah, it answers the questions. But so basically, creativity, according to the model, is the just choosing a random word in the prediction.
Yeah, a random word. Yes,
Yeah.
I mean it's choosing words with lower probability, right? It's not choosing a word that is. I mean, if you set the temperature to 0.7, it's still not picking a word that is completely arbitrary, but less likely than mouse in our case. Yeah.
Thank you.
There is a question from Jacob, disguised as Maxime, in the chat. I don't know if it's easier that you ask the question, Jacob, if you can unmute, maybe then it's easier for Marcus to respond.
I know it's maybe technical for everyone listening in, but it's just a thought that you mentioned that the sentiment analysis using ChatGPT, that was very expensive. And I was wondering if you could use, a different methodology for the sentiment part.
Yeah, for sure.
Yeah. So that's
Yeah. Yes. Yeah, for sure. You could use any kind of tool that you can run for a sentiment analysis that you can think of. We can run it in Python directly. Why not, right? We just thought it would be nice to use ChatGPT once we're dealing with it anyway. But for sure, if it's getting too expensive, then you might think of a different solution.
Yeah, it's probably also good at it anyways. Yeah.
Yeah.
Thanks.
I actually have a follow-up.
I'm muted again.
No. Okay. Sorry. Hello?
I can hear you.
Okay. Did you try rerunning the code just to make sure that you got exactly the same response?
We didn't. Yeah, we reran the code many times, mostly because we played around with one number and then with one question, and then we generated multiple new data files and so forth. But so we did replicate the code, and at times, especially with these answers, when the answer is no or unclear, there have been problems. And that really depended on how we asked the questions. And we played, as I said, we took us a long time to really find the best prompts. And I'm not sure we have found the best prompts yet, but the prompts that we found at least didn't produce very changing results all the time. So we were happy with them at some point, but along the way, for sure, we did encounter problems. Not so much with the yes responses, because, as I said, they are usually very obvious. And once the answer is obvious, it's easy to find. Yeah.
Thank you.
Yeah.
Yeah, it does. Thanks.
Henrik.
Yeah, thanks a lot. I'm super impressed about this work. It's I had no idea that it could be done, and that you can actually explain what's happening in the engine. That's super impressive. I was just thinking about a potential use case in the media area. A typical question is about whether the public broadcasters, so DR in Denmark, for example, whether they are just publishing the same content as the private newspapers and therefore squeezing them out. And I think we've done this kind of analysis. I think the first time Kelle was watching a lot of TV and counting what was in the content. Second time we did something with Python, but I think we could do that kind of analysis much better now.
Yes, I think it can be done. You can apply these techniques to. I don't think you would even need to have a text, right? I think you could technically also apply this to videos, audio files, images, and then extract content from there. So that would work. I haven't done it, but it can be done. Yeah.
Am I allowed to ask one question? Sorry. This is my ignorance about the technology, but because if you use this in litigation, you can't ask it to testify in court. It's a machine. So if I replicate this a year from now, will you be able to have sufficient control on the algorithm that you can use the back version that you used a year ago to get the same answer? I assume you're not going to get the same list if you use this a year from now, even if you have the same temperature settings. So just thinking about those risks is something that I'm interested in.
So, of course, if you use the basis for producing the same result is that you're passing it the same content, right? So this is the premise. But you can always, and this is great with working like with coding, right? You can always go back to an older version, right? You can always use that particular version of Python that I'm using today, or that particular version of ChatGPT that I'm using today. I just have to tell it that. And in fact, I am using a slightly older version because it's updating so frequently, even today, that at some point I had to do that. But yeah, you can do that. Jonas?
Yeah, I kind of have a follow-up question to that. So do you have like some local version of the LLM running on your computer, or do you have to send it to OpenAI to do this? Or
yes,
yeah,
so this is sorry, go ahead. I didn't want to cut you off.
No, yeah, go ahead.
Yeah, very good question. So this particular task worked so well because it was public reports, right? So we could just pass it to OpenAI. So it's not a local LLM. It's standard ChatGPT. So it's all now on OpenAI service. There are ways to get this done. I'm reading currently a lot about this to get this set up to run this locally through. Then I believe the answer is not using ChatGPT, but using an open source large language model that would allow you to do that and to run it locally. But I think it can be done. It might be more complicated because right now the most of support that you find at least is there for OpenAI, but I haven't really tried it with like Claude or Llama or whatever they're called, right? So it can be done.
Thanks.
I think it looks like there are no further questions at this moment. So maybe we just take the opportunity to thank Marco for the presentation. I think it was super insightful, also very clear stories, making something very, very technical also understandable for us, people like me who are, have less understanding of the technical specificities. So thanks also for doing that and for also being excellent with the timekeeping. Of course, us running over now 4 minutes, it's not due to you, it's due to the fact that you had such an interesting presentation so that it triggered many questions. So thanks a lot, Marco, and thanks a lot to all of you for joining in. And I hope that you will join in next time as well. Have a nice Friday and a good weekend when you get there.
Bye.